Hello there and welcome. My name is Theo van Dort and I'm here in the studio with Colin Heathfield, the Technical Sales Manager for Cole-Parmer. Colin, welcome to the studio today.
Thanks
for coming here to make these fantastic videos. Tell us a little bit about yourself.
I'm currently the Technical Sales Manager for Cole-Parmer, as you said. I've worked in the pump industry for in excess of 20 years with several manufacturers covering different technologies, and currently I design pumping equipment, skids, and the whole sort of package, which is what we try and present as a solution, as a technology solution to our customers.
Okay, so today this video is going to be all about the part played by pumps.
Yes.
So take us through this fantastic presentation.
The pumps are vital. We say the part played by pumps. Pumps, we have a slide here showing the globe. They are very much a global product.
Right, so you say pumps are everywhere. What do you mean by that and why?
Everything we do in life is affected, or most of the things we do is affected by pumps at some point. People don't realise how integrated into our life they really are. If you look at the slide, we have a drop of water, we have a sewage works, and we have some scientific works. But if I say to you, this morning, did you have a shower?
I did indeed have a shower.
And then you've used water pumps, from your shower pump to the water that's transported to your house. Mm-hmm. Other things we talk about, grooming products. Do you use any grooming products?
Yes, I certainly do. So much hair gel. No, I'm kidding.
They are manufactured as a combination of products.
Right.
And it's how they're put together in very precise amounts to do a very, very specific job. If we pick something like hair gel, which has to be stiffer, which requires more of one chemical or agent than another, or thinner. Classic one I like is, do you drink coffee?
I do.
Do you have a coffee machine?
I've got a lovely coffee machine at home, yeah.
Coffee machines have a little pump in them.
Right.
And that pump makes your morning coffee. So without that pump, you wouldn't have your morning coffee. And you know, people, the coffee drives them for the day. But also you like your coffee the way you like it. Mm. So if that pump didn't work, you wouldn't get your coffee. Another classic example of a liquid that's not pumped, that is pumped, but people don't think of, is toothpaste. Because you will, like everyone else, get toothpaste out of a tube, just squeeze the tube, and you have toothpaste on a brush. That has to be made, that has to be pumped into the tube, that has to be pumped around a system. That pump is a very, very different sort of pump from the one used in the coffee machine to make your coffee, or to put the water through to make the coffee. We influence what the pumps do because they have to do to make the products what we use.
Right.
But then the pumps influence us because there's only certain ways they can do it.
Right.
At Cole-Parmer, we have currently, I think it's 22 different pump technologies that we can offer, and that's just a selection of what is available globally. I'll take you on what I call the journey through pumps.
All right, brilliant. Okay, so what is a pump in basic terms?
A pump is a way of moving a liquid from one place to another. So you'll have a start point, be it a tank, be it a container, be it a river, be it a reservoir, and then you want to move that product to somewhere, be it the toothpaste tube, be it the coffee cup. The pump is the means and the heart of it that moves that liquid across. It's the technology that enables us to move that liquid. And I talk very broadly about the liquid as well, because I've already said we have water, which is a very fine, easy liquid to move. We have various chemicals. We use those chemicals to make up everything we use, from the grooming products to foodstuffs. Another fine example is vegetable soup. Back to the toothpaste, to where we want it to be. Vegetable soup is in the can, toothpaste is in the tube. And it's this pump, this technology, that enables us to have this lifestyle.
Okay, and where does the pump fit into this?
The pump, as I say, really is the heart of the system. The pump technology affects how the liquid moves. If I go back to vegetable soup, when you open a can of vegetable soup, you like it to be a nice liquid with some lumps of carrot in there, some peas and things like that. If I use the wrong technology, it's all liquidized as it goes through the pump. Whereas if I use the right technology, it's made and it's moved cleanly to the can and then to your plate. Right. The toothpaste, very, very abrasive, very hard. It's not abrasive if you use it as a toothpaste gently, but if you pump it at high velocity, it can polish very highly. So you have to pump that in a different way. And these are all things the pump technology does when you pick the right technology.
And things that we take for granted.
But yes, yes, very much. Vice versa, if you pick the wrong technology, it changes how it works. So I've just clicked up another slide there just to show, because we're going to talk about the suction side. So I mentioned to you we pull the liquid from a point, from a bucket, whatever. So we call that the source. And then the route that has to the pump is the suction pipework, or the connecting pipework on the suction side.
Okay.
Within that, you may want to measure the temperature, the pressure, the flow rate, which is the rate at which the liquid is moving. You may want to bring it a long distance, a short distance. These are all considerations that we need to look at very carefully when selecting the pump.
Right.
But that's what we call the suction side. We then come through the pump,
Yeah.
and we come to the other side, which is the discharge side. This is where we want the product to be. So if I jump to your coffee machine again,
Yeah.
you've got a little water tank on the back.
Yes.
So the suction side is pulling it from the water tank into the pump. Then the discharge side is where we want the coffee to come out into your cup. The connecting pipework and associated equipment is the point that lets the coffee into it to give it the flavour, is the point that heats the water up, is the way that it measures that the water is the right temperature and restricts the rate at which it flows into your cup. So this is associated equipment in the discharge side of the system.
Okay. It's wonderful to break it down like this, because you just look at these machines and you go, oh, they work like that, and it's fascinating to actually learn about the inner workings.
There is a lot more that goes on within the unit than people realise, and this is why I call it the key to a flow system.
So, Colin, what do you need to know to pick a technology?
I'm glad you asked that question. It's one of the most difficult points we actually have within what I call the pumping world. There's a lot of times when people actually aren't sure, or they phone you up and say, I need to pump this. And, okay, you need to pump it. How much do you want to pump? Oh, I don't know. And then you say, well, how quickly do you want to pump it? But if we drill down, we can actually find out, it's 4 bucketfuls and your bucket is this size and you want to move that much in an hour. Then we can start to find out.
Right.
But we do tend to go back, if I could take you to the slide, to some sort of core basics. One is the liquid or the media. Now, I was talking to you earlier about examples of liquid or media. And we were talking water, coffee, toothpaste, hair products. These are things people understand because they can relate to. Foodstuffs. And foodstuffs have a different way of being treated because you don't want to damage the product, but you need to move it. It may be at temperature. You then get to oils and things like that, or the chemicals. We are very, very strong within the pharmaceutical industry and within pharmaceutical manufacture with some of our pump technologies because it gives specific advantages. And theirs are very much, they can be recipes, they are powders dissolved. There is many, many different things. If you look at then chemicals, solvents, these are all things that are not used in everyday, in your everyday life, but behind the scenes, they're very, very prevalent in what we do. So the liquid is the first question I ask.
Okay.
And that liquid can also have solids in it. We define it as soft solids and hard solids. We can have large solids, small solids, abrasives. If you have silica in it, which is sand, it's abrasive. If you pump a liquid with sand in, an abrasive, you can wear a pump out because it's used for shot blasting. So we have to look at that. Then we move on to flow rate, and this is how much you want to move in your timescale. And some things you want to move large volumes will steer you towards one pump technology, other things slower, another pump technology. And then going back to toothpaste, very, very difficult to pump, very, very difficult to pump fast. Then we move on to, we were talking the key to the flow system, the suction and discharge side. So where it's coming from and where it's going to, not just what you're going to put through the pump, but we like to talk about, as I say, the journey to pick the technology. So it's the source to the discharge point and what you're doing to it in the various different stages on that journey. And then finally, we go to the needs. We have accuracy and repeatability as two examples here. But the needs are, do you need it to give the same dose each time? Do you need it to give the same size each time? Is that your critical point? Or does it need to arrive at your point at a specific quality?
Okay.
If we go back to your coffee, doesn't matter which, but you may like a specific type of ground coffee that gives you a specific flavour. If the pump pumps the water too fast, the coffee will be too diluted, you won't get that strength of taste. If it pumps it too slowly, it'll be the opposite. You won't have enough and it'll be too strong and your cheeks will suck in as you try and drink it. So the pump technology has a very, very direct effect on what you're trying to do as your end product or your end result. There is ways we can look at these and ways we can talk the customer through these at Cole-Parmer.
So, Colin, are there other areas that would affect the choice of pump?
Yes, we call these pump technology considerations. They are sort of less direct to what the pump's actually going to do, but very, very important for the owner of the pump, for where it's going. We've listed 4 of them here. If you look at one is cost of ownership. A lot of people don't realise different pump technologies can give you a very, very different cost of ownership. Some will use a lot more spares, could have a cost implication in that way, but have very easy maintenance. Some will have a long running life, but when you do actually have to maintain them, they are very, very expensive because it's what I call back to workshop with lots of components. So we try and engage with, what are you trying to do with the pump? How long do you want this pump to run for? If you pick something like the Masterflex Peristaltics, the pumps can actually run for up to 10 years. We've achieved in excess of that. It depends on how hard you use it. But then you have tubing, which is a consumable. If you pick other types of pumps, like some of the centrifugal pumps, they're a different sort of pump. They have a more efficient running, but then when they need servicing, it's a much higher cost. The peristaltic is a very low cost service. There's hardly anything to do.
Right.
The centrifugal pump is a much higher service cost. And if you look at progressive cavity, that's also a high service cost, but a long run time.
And these are all things that you will advise your clients when they are asking you, how to spec out for a particular system.
Myself and the team, we always talk about and discuss these things. We also look at another one's area or environment, because if you've got something going in a laboratory, it's nice and clean. If you've got something going in a production area, it might be washed down. If you go to dairies and dairy milk processing plants and environments, one of their critical cleaning criteria is that they wash down or steam clean a lot of the products to ensure that there is no, their hygiene regulations are met, which are very, very stringent. If you steam clean something, you may affect the seals on it. So we have to know this so we can put different sealing arrangements in there.
Right.
It could go outside. If it goes outside, it needs a different waterproof sort of enclosure. It needs to be tougher. Someone might drive into it with a fork truck, so it might need to be more solid. It really can be as basic as that. And then we look at what we call explosion-proof areas, ATEX, and then that's another set of considerations for them. And then we briefly touched on maintenance, and maintenance is very, very important. There is one type of pump that my 5-year-old daughter can do the maintenance, which is the peristaltic. She just changes the tube.
Right.
The reason I know this is because I left a pump with a tube in the dining room and came back and she was opening it, taking the tube out, putting it in and closing it. So maintenance can be that easy.
Okay.
But if you then go to centrifugal progressive cavity pumps, it needs a trained fitter back to the workshop to pull it apart, clean it down and work on it. So maintenance, and if you had a pump or something that was sampling for a river that was 3 fields away and in a little remote hut, you don't want to be going to that every day. You want to go to that once every 6 months in your Land Rover to take the parts and work on it.
Right.
So it's a very, very important technology consideration. And then we have hygiene and others. We say hygiene because a lot of the food equipment has very, very critical regulations for bacteria growth testing and such like. So you have hygienic pumps with hygienic connections. So it's not just a food grade material, it's a fully hygienic material. Plastic to coat with certain materials or external materials. UV stabilizing for paint coatings and other coatings. If it's in sort of the Middle East, the Far East, it's much warmer. It's the whole technology consideration is a very, very broad area.
Understood. Okay, so what's next?
So, coming back to my slide, we're talking about selection of the pump. We're talking about the suction side. We're talking about the discharge side. The thing is, it's the whole technology. It's the whole process. And what I try and do is say to people, it's not just the pump, it's the whole system.
Okay.
And then with this training, we go on to talk about some of the systems we can offer, or some of the pump technologies we can offer from Cole-Parmer, with the pump at the heart of the system.
So, Colin, that was the key to a pump system, from the suction side all into the pump, the discharge side, and also the things that a client will need to consider when choosing the right pump. But I guess that's where Cole-Parmer can really help them out.
Our team is there to help them select, but those are key points and questions we will be steering towards and asking, because the pump is, as we say, at the heart of the system. The next stage for us is to talk about the technologies and where these then fit into that system. This is a slide we have to show some of the technologies that are available at Cole-Parmer.
Okay, and based on those considerations, you can now choose which video you would like to watch, so that Colin and the team will explain exactly how they work. See you in the next videos.